Can you hear me, students? Can you hear me? Can you hear me? Hello, students. Can you hear me? Hello. 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 Is anyone willing to respond? Or shall I mark everyone absent? Hello. Hello. So why don't you respond in the mic?
Hello, sir.
Okay, fine. So today we'll be starting with oscillatory motion. Okay. So oscillatory motion we'll be starting with that topic today. Can you see the screen? I have shared something, students. Hello. Hello.
Yes, sir.
Okay, so let us start.
Motion. What is meant by the periodic motion? It is a motion that is repeated regularly at specific time intervals. Examples of periodic motion are the oscillatory motion, the wave motion. The concept of oscillatory motion. Have you noticed the movement of a seesaw? It goes forwards and backwards around its position of equilibrium. This type of motion is known as oscillatory motion. The following activity explains the concept of oscillatory motion. Activity 1. Defining the concept of oscillatory motion. The materials and tools. a pencil, a thread 30 centimeters long, a quarter-pound coin. The steps. Number 1. Set up a simple pendulum by winding one of the ends of the thread at the middle of the pencil, while the other end is attached to the coin, which represents the oscillating body. Number 2. Hold the pencil with your left hand and pull the coin to the right, then set it free. Observation. Number 1. What do you observe regarding the motion of the oscillating body? The coin. We observe that the coin oscillates at its equilibrium position. Number 2. What is the relation between the values of displacements of the oscillating body on both sides of the equilibrium position in every oscillation? We notice that the displacements are equal. Number 3. At which position the velocity of the oscillating body becomes maximal, and when does it decrease? The velocity of the oscillating body becomes maximal at its rest point, and it decreases when it moves away from its rest point. Conclusion. Number 1. The periodic motion which is made by the oscillating body at the sides of its rest position, and which is repeated regularly and at specific time intervals, is known as the oscillatory motion. Number 2. The velocity of the oscillating body is maximal at its rest position, and it decreases when it moves away from its rest position. Wonder. Have you asked yourself about the relation between the velocity of the pendulum and its kinetic energy? When the kinetic
Can you hear clearly, students? Hello? 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 Students, can you hear? Okay. Okay. Fine. If you have any doubts, you just ask me, okay?
energy of a pendulum increases, its velocity increases. Real-life applications. The microwave. The idea behind the operation of the microwave is that microwaves make water molecules of food vibrate. This forces molecules to collide with each other. This produces a great amount of heat energy that gets the food to cook faster. The pots to be used inside the microwave oven should be made of pottery, ceramics, or glass. We never put cooking pots made of metal inside a microwave because metals reflect microwaves back to the source. Activity 2. Graphical representation of oscillatory motion. The materials and tools. A smooth paper tape winding around 2 rolls. A spring, a weight, a nail, a pencil. The steps. Number 1. Fix the pencil to the weight and hang the weight at one end of the spring. Number 2. Hang the other end of the spring using the nail after having it fixed to a wall, in a way that makes the pencil tip touch the paper roll exactly in the middle. Number 3. Pull the weight downwards, then set it free. Don't forget to wind the paper roll regularly. What is the shape formed on the paper roll? A representation of oscillatory motion is formed on the paper roll. As you notice, this simple harmonic motion is considered the simplest form of the oscillatory motion.
Sir, hello.
Yes. Hello.
As routine for second sessional examination is
If you get
come out just now. So can we know that the syllabus?
okay, wait a minute. Wait a minute. Hello. Hello.
In here?
Can you hear me?
Yes, sir.
Okay. For the second session, what we'll do is we'll have the questions from the whole portion that is being taught yet till now. Understood? It will be a basic revision for you people also, and it will be nice for everyone also because exams are coming now.
From the beginning, sir.
Yeah, from the beginning. The exam is on 7th now. From 7th onwards, we'll be having exam now. Hello. 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 Hello.
Yes, sir. First period is the engineering mechanics from 9:30.
Yeah, yeah, I know that. I saw the routine. So from 7th, you will be having exam now. 7, 8, 9, 9. Right. Hello.
Yes, sir.
Okay, I'm having terrible network issues. Just a minute, huh? Just coming and going, coming in. So that thing only. So till today, what has been taught, I'll give you give from that portion. Is it okay? It will be a revision for you people also for the finals.
Okay, sir.
Okay. Okay, na? Hello.
Fine,
Hello.
sir.
You just tell all of your friends. I guess everyone is though everyone is connected, but I don't think so. They are active. Ah, so only a few people are replying me in the chat and everything. So I don't think so that maximum of your friends are active. So just inform all of your friends. Okay. Let us get back to the video. Can you see the screen? Can you see the screen?
Yes, sir.
The
Yes, sir.
oscillatory motion. All of us have seen the pendulum of an old clock. It's a weight attached to a metal rod, moving at the sides of its rest position, to the left and to the right. Can we form a simple pendulum similar to that of the clock? Of course we can. Number 1. Get a weight and get it attached to a thread. Number 2. Hang the thread at a stand. Number 3. Pull the weight towards the right and then set it free. We notice that the weight moves to the right and to the left at the sides of its rest position. If we record the times this pendulum takes to complete 10 movements, we will notice some properties of this oscillatory motion of the pendulum. What are these properties? The first property of the oscillatory motion is that the oscillating body oscillates at the sides of its rest position. The second property is that the velocity of this oscillating body decreases as it moves away from its rest position, and it becomes maximal when the oscillating body passes its rest position. But what is the reason beyond the decrease of the pendulum's velocity as it moves away from its rest position, while it becomes maximal when it passes its rest position? We know that the gravitational force controls the motion of objects that are near to the Earth's surface. So when the pendulum moves against the gravitational force, its velocity decreases. But when it moves towards the gravitational force, its velocity increases. That's why the velocity of the oscillating body decreases as it moves away from its rest position, and increases when it passes its rest position. If we watch the motion of this pendulum for some time, we will notice that it repeats certain motions. This motion is called complete oscillation. What is meant by the complete oscillation? The complete oscillation is known as the movement made by the oscillating body when it passes a single point in the path of its motion 2 consecutive times in the same direction. What does that mean? Let's look at the pendulum once again. When we pull the pendulum towards the right, then set it free, it passes through point B, then to point C, then again to point B, and finally to A again. So we can say that the pendulum moves from A to B, then from B to C, then from C to B, and finally from B to A again. This means that the complete oscillation consists of 4 displacements. What do we mean by 4 displacements? It means 4 stages for the motion of the pendulum during its oscillation. What shall we call each displacement? We will call it amplitude. Now choose the right answer. The complete oscillation consists of 2 displacements, 3 displacements, or 4 displacements. Well done, 4 displacements. So we can define the amplitude as follows. The maximum displacement achieved by an oscillating body away from its rest position. Let's now answer this question. It says, give reasons. The complete oscillation consists of 4 displacements. Because the complete oscillation is the movement made by the oscillating body when it passes a single point in its path of motion 2 consecutive times in the same direction. But we have to underline 2 consecutive times because it explains why the complete oscillation consists of 4 displacements. Exercise. Look at this graph. Number 1. In which graph the amplitude is larger? The amplitude is larger at graph 1. Number 2. How many complete oscillations are there between point X and point Y in each graph? In the first graph, there are 3 complete oscillations. In the second graph, there are 4 complete oscillations. Frequency. Look at this pendulum. If we watch this pendulum for a specific period of time, we will notice that it makes some oscillatory motions. But how can we express the complete oscillation this pendulum makes in 1 second? We can express the number of complete oscillations the oscillating body makes in 1 second with the definition of frequency, F. So we can say that frequency is the number of complete oscillations the oscillating body makes in 1 second. Drawing on the definition of frequency, we can define frequency law. Frequency law is frequency, F, equals the number of complete oscillations over time in seconds. This means that time has to be measured in seconds, and if we are given time in minutes or hours, we have to convert it into seconds. Frequency is measured in Hertz, Hz, named after the German scientist Hertz. Multiples of Hertz, kilohertz, equals 1 times 10 to the power 3 Hertz. Megahertz equals 1 times 10 to the power 6 Hertz. Gigahertz equals 1 times 10 to the power 9 Hertz. Exercise. Calculate the periodic time, T, and frequency, F, of an oscillating body that makes 300 complete oscillations in half a minute. Time equals half times 60 equals 30 seconds. The periodic time equals time in seconds over the number of complete oscillations. T equals 30 over 300 equals 1 over 10 equals 0.1 second. Frequency, F, equals the number of complete oscillations over time in seconds. F equals 300 over 30 equals 10 Hertz.
I have this question for you. What do you mean by frequencies? Does this mean that we have to learn body language and vocal writing so we can deliver our content? Or it means we have to organize our content in such a way?
Students,
Yes, sir.
okay, I'll share the video. You just watch it. I'll just you just understand, and if you have any doubt, you can ask me.
The periodic time, T. What's meant by the periodic time? When an oscillating body makes a complete oscillation, it takes some time. The time taken by an oscillating body to make a complete oscillation is called periodic time. So we can define the periodic time as the time taken by an oscillating body to make a single complete oscillation. But the question now is there a relation between frequency and periodic time? If we look at the periodic time law, we notice that the periodic time equals 1 over frequency. So we can say that the periodic time equals time in seconds over the number of complete oscillations. So mathematically speaking, we can say that the relationship between the periodic time and frequency is an inverse relationship. This means that when frequency decreases, the periodic time increases, and vice versa. Let's now ask a question. It says, give reasons. The frequency of an oscillating body increases when its periodic time decreases. The answer is because the relationship between frequency and the periodic time is an inverse relation. So frequency equals 1 over the periodic time. The periodic time equals 1 over frequency. And if we multiply frequency by the periodic time, we will get what? We will get 1. Frequency times the periodic time equals 1. Let's now have some examples. Example number 1. An oscillating body makes 600 complete oscillations in half a minute. Calculate A, the frequency, B, the periodic time. Since frequency equals the number of complete oscillations over time in seconds, equals 600 over what? Don't say over half a minute, because frequency is calculated in seconds. Half a minute equals 30 seconds. So frequency equals 600 over 30 equals 20 hertz. And as you know, hertz is the measuring unit of frequency. It equals a complete oscillation per second. Let's now calculate the periodic time. The periodic time equals 1 over frequency equals 1 over 20 seconds. So the periodic time equals 1 over 20 seconds. Example number 2. An oscillating body makes 720 complete oscillations in a minute. Calculate A, the frequency, B, the periodic time. Since frequency equals the number of complete oscillations over time in seconds, equals 720 over 60, equals 12 hertz. Therefore, the periodic time equals 1 over frequency, equals 1 over 12 seconds. Choose true or false. Frequency times the periodic time equals 1. Very good, it's true. The periodic time of a pendulum depends on the length of the thread, not on the mass of the weight attached to it. Exercise. Look at the opposite figure. What is the periodic time of the oscillating pendulum? The periodic time equals the amplitude times 4 equals 0.5 times 4 equals 2 seconds.
So students, I hope everyone is hello. I hope it is clear for everyone. If you have any doubts, you can
Yes,
ask me.
sir. Yes, sir.
sir.